students, welcome to Alpha's e-learning program mathematics class. In previous session we have started the concept of extreme values in trigonometric functions, and we have observed few values just basing on the concept of range of our known trigonometric functions, that is -1 less than or equal to sin x less than or equal to 1. In the same way cosine value also, and if I take suppose square 0 less than or equal to sin square x less than or equal to 1. So basing on these, in the same way cos square x also, like that secant square etc. Basing on these, yesterday we found here sum of values, that is right, sin square x plus cos to the power of 4x, or sin power 4 plus cos power 4, sin power 6 plus cos to the power of 6, cos power 4 minus sin to the power of 4 etc. We found in previous session. What about extreme values, minimum as well as maximum values, how to find? Now suppose a function is of this form, that is sin x plus cos x. Then we have observed here we can multiply divide by root 2, thereby you can convert this one as here root 2 times sin of again x plus pi by 4. But students, what happened here, you know about sine range, and thereby if I write -1 less than or equal to sine of whatever angle here, it is less than or equal to 1 as far as domain is nothing but here real numbers is concerned, right? And again we multiplied by root 2, thereby simply we can obtain least value as well as greatest value. But every time we can't expect the coefficients are one and the same. Sometimes the coefficients are like this, 3 sin x plus 5 cos x, or it may be here some 4 cos x minus 5 sin x. Like this here the coefficients may be different. If coefficients are one and the same, plus k, you can take it common and you can make use of the same relation. Whereas if coefficients are different, then what to do? To this one we can here derive one formula, and that is one of the important formulae in total trigonometry, right? And again as usual I am telling you, whatever concepts minimum maximum now you are finding, these are not confined to only this chapter, right? And now let us observe here students a formula, that is suppose if I am taking f of x is equal to a cos x plus b sin x plus c. Okay, so this is our function. Now these a and b coefficients, they can be one and the same or they can be different. A, b, c are here real numbers. What is the variable? The variable is here x. Whenever you are defining any function in terms of x, then you have to observe the x value is variable. Other terms, that is a, b, c are here any kind of real number. That means whatever real number x you substitute here for all x belonging to the domain of f of x here, what about the least among all values, and what about here greatest among all values? X you can substitute here 1 degree, half degree, or else pi by 3, pi by 6 etc. And that means here all real numbers if you substitute, then we get here f of 1, f of 2, or f of 1 by 2 degree, f of pi by 6 etc. Among all of them, what is the least and what about here the greatest? That is our interest now, keeping a, b, c fixed. The only variable is here x value, right? And now once you got this, actually again we want to make use of known function, that is sine or cos. But you can observe here both the values present. If it is cos square, I would have write it as 1 minus sin square, but it is a first degree. First degree means under root of, you have to write 1 minus sin square. Again the problem will be complicated. So without here taking square roots or anything, how to solve this problem? I want to convert the entire value in terms of a single function. In terms of single function means it can be cos or it can be sin. Then how to reduce in terms of single function? Suppose if I take here this a value, it is nothing but here it is a value real number which can be less than 1 or it can be more than 1. If I take as it is a equal to suppose sin alpha and b equal to suppose cos alpha, then what will happen here, sin alpha cos x and plus cos alpha sin x. Thereby this value is how much here? It is sin of alpha plus x. And you know about here the minimum and maximum values of sine function. Thereby -1 less than or equal to you can approach. But students, the problem is here I cannot take directly A as sin alpha. The reason is, what is the reason here? You know sin value or cos value, they are always in between what? Minus 1 and plus 1, right? As they are in between minus 1 and plus 1, therefore directly you can't take this one. Again, suppose if I have 2 cos x plus 3 sin x, right? And if I take let 2 equal to sin alpha and let 3 equal to cos alpha, it's a big blunder, because sin alpha or cos alpha, they are always in between minus 1 and plus 1. Hence you cannot take sin alpha is 2 or cos alpha is 3, etc. That's why here directly don't take these values as sin or cos whenever this kind of expression given. Then what to do here? We multiply, divide with a particular quantity, that is nothing but here a divided by under root of a square plus b square into cos x, and again plus b divided by under root of a square plus b square and into sin x, right? As we multiplied divided by this quantity, therefore immediately multiply here, that is a square plus b square and existing c as it is, right? Now in this way we got. Now why again the particular value root a square plus b square? You could substitute, multiply, divide with any other value also. Why only this kind of particular value? Here also some strategy is there. What is the strategy? Suppose you want to get this value as sin value, immediately this must be here cos value. Or if I write this one as cos, then this must be here sin. That is the reason we want to write a special value, that is under root of a square plus b square. What is the special category here? Because if I take this one as a, this as b, then this would be how much here? A square plus b square with square root. Or you can take this value as how much here? A, then simultaneously this value will be here b. These two you can consider anyways. But this has to be here how much? Root a square plus b square. Thereby if I take here alpha, then you could write sin alpha as opposite side by hypotenuse and cos alpha as adjacent side by hypotenuse, right? So that is the purpose why we are writing here particular value, that is under root of a square plus b square, other than any values, right? Now suppose if I write in this way, this is cos x, and this one here I kept a and here b. You can write here a and here b also. Then students, what about here this entire value? It is nothing but sin alpha. And what about this entire value? Here it is cos alpha. So this is sin alpha and this value is here cos alpha. And in particular, what about tan alpha? Here it is a by b. So simply we can say where a by b is nothing but tan alpha. Understand? Then what about now our formula? This is under root of a square plus b square, and this entire value is nothing but sin of alpha plus x. Understand? And this value is plus c alone, right? And now here you can write the same value cos alpha, simultaneously this would be here sin cos alpha sin alpha, then cos x cos alpha plus sin x sin alpha, it is again cos of x minus alpha. In that way also you can take no error at all. Now students, this is our value. Now you need to find here minimum and maximum. To that purpose we are making use of the known term, that is sin, because the domain is here all the real numbers. As long as domain is all real numbers, sin value is, however the other terms are present, then also sin value is in between minus 1 and plus 1. So let's make use of this. That is the purpose why we have changed everything in this way. Now I am writing minus 1 less than or equal to sin of alpha plus x less than or equal to 1. So known value we used. Understand? This is, we know that this is the value. And now this is multiplied by this quantity. In previous session also we have done By taking a known range, then we converted the entire inequality in terms of the problem, whatever here requirement. Now this value is multiplied by what here? Root a square plus b square. Therefore, minus root of a square plus b square less than or equal to root of a square plus b square into sine of alpha plus x, and this is less than or equal to under root of a square plus b square. Up to this it is okay. Now to this, what is the value you are having? Extra plus c. So let's add here c value. Then c minus root of a square plus b square less than or equal to c plus under root of a square plus b square sine of alpha plus x, and this is less than or equal to c plus how much here? Root a square plus b square. Got it now? Therefore, you got the entire term, that is nothing but our requirement, that is f of x. So to this function f of x, students observe what is the least value you got? C minus root a square plus b square. Greatest value, it is c plus root a square plus b square. A and b are coefficients of sine and cos, and c is which is independent of these x values. Understand? So c is here constant, a and b are here nothing but sine cos coefficients. So students, this is the formula when f of x is given as here. How much the value is? Nothing but a cos plus b sine plus c. Therefore, we can say range of, understand, range of f of x, that is a cos x plus b sine x plus c. So range of this function, range means it is here closed interval we write, and first we write minimum value. The minimum is c minus root of a square plus b square, and maximum value, that is c plus under root of a square plus b square. So this is the condition we got, and this is our minimum, and this value is here our maximum. Got it? Therefore, whenever you come across with this kind of function, so what are rules and restrictions to make use of this formula? One of the rules is the angle must be here one and the same, right? X and x, one is here 2x, the other 3x, you cannot make use. Angles must be one and the same, and the other condition is degree must be here 1. Then only you can make use of this formula. Moreover, students observe here one more condition also, that is this entire value is sine of, right? And it has to be always in between minus 1 and plus 1. Then what about here? Only this particular value. This particular value is nothing but here f of x minus c, right? We did not add here c value. So f of x minus c value, and it is in between minus root a square plus b square into this one. So if I write that particular value, that means this entire value we got, and thereby you got here this kind of condition. And next one, students, observe carefully here. This condition is one of the important values, that is whenever they asked you about find minimum and maximum. Suppose a problem is given as 2 sine cube x and plus cos 3x, right? And what about here? Least value, greatest value. You cannot make use of this formula here. The reason is, first of all, it is in the power, not as a multiple, right? And here what should be the degree? It must be only 1, but here degree is 3. Therefore, you can't make use of this formula here, and we use some other method. Suppose a problem is given 2 sine x plus cos 3x. Understand, if it is given in this way, okay, first degree satisfied, but again another error. What is the error? This is x and this value is here 3x, both are different. Again, you can't make use of this formula. So to make use of this formula, the conditions both are must be same, and at the same time degree must be here 1. Now let us observe, students, here some values, that means some examples. Let's have a glance one by one. Let us solve here. These are some problems which they asked here minimum and maximum values. Understand? Then how to find here minimum, maximum? First you have to observe, are they in our standard form or not? Observe, this is 3x and this value also here 3x, and here 8 and 15 first degree 100% pakka you can make use of the formula. However, these, but the only thing is here, these must be here same value. That is the only thing you have to observe. Therefore, you can make use of the formula. Now, a and b you can take anyways because you are using here under root a square plus b square. So, now our problem is here f of x is 8 cos 3x and minus it is 15 sin 3x, right? And now how we can make use? Here c is absent, that means c value 0, a equal to 8 and b equal to minus 15, right? And now the minimum value or maximum value, directly you can write range is nothing but closed interval c minus 0 minus, and of course all of you aware of this one 8 and 15 combination. You know what is the value? It is nothing but 17. Therefore 0 minus 17 comma 0 plus 17. Hence what is the answer here? Minus 17 comma plus 17. Got it? Therefore this answer is here, this one, this is our minimum value and this is here the maximum value of given expression. Simply you can substitute, nothing to worry, only observe here whether these conditions are satisfying or not, that's it. So what we have done, under root of a square plus b square, 8 square plus minus 15 whole square, that is under root of 64 plus 225. So 289, 289 means it is nothing but root of 289, 17, right? And hence you got these kind of values. Now students, let us observe the second problem. What is the second problem you are having? The second problem is 2 root 2 cos plus sin x, right? Again, what is our observation here? This is your x value. Angles are one at the same and degree is here 1 and 1. So directly let's make use of the formula. Then what will happen here? The range is nothing but, for second problem, right? The range is nothing but c value, observe. What is c value here? The c value is here 0. Therefore 0 minus under root of 2 root 2 whole square plus 1 square, right? A square plus b square, the coefficient is here 2 root 2, whereas here it is 1. Understand? And next other value 0 plus under root of, again same kind of value. Then what is here the answer? It is 8 plus 1, that is 9. So root 9 means it is 3 minus 3 comma same value plus 3. Hence range of this function is nothing but how much here? Minus 3 comma plus 3. And next let us enter here to the third problem. Now observe students, third problem is not that much easy. That means directly it is not expressed like as 1 and 2 problems. However, these values given, here x given, whereas here it is x plus pi by 4 given. But degree is the same, that is here degree is 1 and here also degree is 1. Only thing is angles are different. So directly don't make use of this kind of formula. Then what to do here? Let's make use of here compound angle concept. Sin of x plus pi by 4. Understand? So third problem, whenever I am solving here, to do here third problem, we write cos x and next value plus 3 root 2. And now let us expand sin of a plus b, sin of x plus pi by 4, that is sin x cos pi by 4, that is 1 by root 2, plus cos x sin pi by 4, that is 1 by root 2. So this problem students we are doing. Okay, now it is cos x and after that we expanded sin of x plus pi by 4. As you are aware of sin pi by 4 cos pi by 4, directly I wrote those values. Understand? And next one, here 1 by root 2, here also you have 1 by root 2. Therefore let us cancel that value here with root 2. So you can cancel, right? And now this is cos x plus how much here? 3 sin x and plus this is nothing but 3 cos x. Of course plus 6 is there extra, that also we write here plus 6 and here I am writing plus 6. Got it? And now finally observe it is 3 plus 1 4. Okay, so 4 cos x and plus 3 sin x plus what is the other value you got? 6. So this is our f of x, students. Exactly now it is in our standard form. A is 4, B is 3 and our C value is nothing but 6. Understand? Then what about here least value? The minimum value is nothing but here C minus. What is our C in this problem? It is 6. Therefore 6 minus under root of 4 3 combination, you know it is 5. That is, you are writing like this, and here when 4 and 3 are coming in this way, always you know it is nothing but 5. Therefore it is here 1. And maximum value if I take, then it is 6 plus under root of same thing, that is 6 plus 5. Therefore what is this value? 11. Now what about here sum of least and greatest values? 1 plus 11, that is 12. So they may ask in any way, so the minimum you got 1 and maximum you got how much here? 11. Understand? Now let us observe, students, again the fourth problem. So what about here fourth problem? F of x is sin x into sin cube x plus 3. Understand? Sin x into sin cube x plus 3, and after that plus cos x into cos cube x plus 4 plus half of this. Seems to be entirely different. We cannot expect this kind of value. We can express in the standard form like this. Understand? But we have to think, because we have so many formulae in our hand from the concepts of multiple, submultiple as well as compound angles, etc. Therefore immediately you shouldn't give up to our known values. You have to think 1 or 2 times any known formula can we obtain or not. Observe the first product. What is this value? Sin to the power of 4x, right? And plus symbol is there, and immediately plus cos to the power of 4x. And you know very well sin power 4x plus cos power 4x. What is that value? It is 1 minus half sin square 2x. So again here you are having half sin square 2x. So nothing to worry. Some terms now they are going to get cancelled. That means here we should be here aware of our all known formulae. Then only easily you can do any of these kind of problems. Now let us have here, that is f of x equal to, first I am taking sin to the power of 4, right? And after that plus this is 3 sin x. Got it? 3 sin x, and next value plus cos to the power of 4, right? And next this value is plus 4 cos, and next value you are having plus half sin square 2x, and then it is nothing but here 5. Got it? And now what is here? Sin power 4 plus cos power 4. It is the known value, that is nothing but 1 minus half sin square 2x. Understand, students? And next value, this is 3 sin plus 4 cos. As it is I am writing 3 sin plus 4 cos, and later this is plus half sin square 2x. Okay, and then this is nothing but here 5. Now let's cancel here these two terms, students. Then what is the value you got? 3 sin x plus 4 cos x plus how much it is? 6. Understand? That means you got here again the previous model. So immediately just by observing the problem you think that it is not of the standard form, therefore we have to search for any other methods, but nothing necessary. Directly you can make use of this by using our previous formulae. Therefore finally, students, what is the value you got here? It is nothing but f of x is equal to nothing but how much you got? It is 4 cos x, right? And after that plus 3 sin x, and next value it is 1 plus 5, that is nothing but here 6. Got it? Then what about here least and greatest values? The least and greatest values is nothing but minimum is c minus 6 minus under root of 4 square plus 3 square, that is 6 minus 5, and it is equal to how much here? 1. And maximum value, that is equal to 6 plus under root of this, that is 6 plus 5 equal to 11. And then here sum of extreme values they have asked here, and it is nothing but how much, students? 1 plus 11, it is 12. Okay, so in this way you can find here, even however the term problems given, you can reduce in our standard form. Not of course all, but few of them you can reduce. Now let's have a glance again this one also. So again students, this problem is again seems to be not of our regular model. Okay, that means in this form. Then just let's have thing here whether we can reduce this concept also in terms of our standard form or not. Okay, then how to reduce? This is of the form cos square theta. Okay, so every time you are, I think you have been observing, we are not at all ignoring our previous formulae. So whichever problem you want to solve, almost 90% of the problems you must make use of every time are all old previous concepts. Let us observe here cos square theta. What is cos square theta formula? 1 plus cos 2 theta whole divided by 2, which we deduced in the chapter of multiple and submultiple angles. Now what about next sin minus cos whole square? That is sin minus cos whole square, you can write sin square plus cos square minus 2 sin cos. Got it? Now I am making use of those results in this problem. So students, here this pi by 4 minus x is nothing but our theta. So I am writing the given problem as, suppose f of x is equal to, it is 1 plus, right? And in terms of theta, how much you are having here? This entire value is your theta. So in terms of theta, what is the value you got? 1 plus cos 2 into pi by 4 minus x whole divided by how much here? 2. Understand? And next sin minus cos whole square. It is 1. Sin square plus cos square is 1 minus 2 sin x cos x. What is the value? It is sin 2x. Therefore, this is sin 2x. Understand students? Now, again here you multiply inside. Then 2 into pi by 4 is nothing but pi by 2. And minus this value is 2x. Therefore, here we are writing 1 by 2. I am splitting the fraction 1 by 2 plus 1 by 2 times it is sin pi by 2 minus 2x cos value. Understand? So cos, if I write pi by 2 minus 2x and plus 1 minus this is here sin 2x. Got it? Now 1 by 2 plus 1. 1 by 2 plus 1, what is that value here? 3 by 2. So this is 3 by 2. And next value, it is sin 2x, right? Plus half sin 2x. And next value is minus sin 2x. So 1 by 2 minus 1 means it is again minus half. Hence, finally, what is our value here? The f of x value you got here, finally, it is nothing but first term is 3 by 2 and next value it is minus half sin 2x. Got it students? That means here in the entire problem, you are not finding here any cosine value. Then what about here cos 2x coefficient? That value is 0. Understand? That means the same problem you can make use as here 0 into how much here? Cos 2x. Got it? Therefore, you can make use of simply this formula, or else students already you know what about our values, that is minus 1 less than or equal to sin less than or equal to plus 1. That also you can make use. So if I write in this way, then minimum value is how much? C, that is 3 by 2 minus under root of a square, that is 0 plus b square 1 by 4, right? Therefore, this is 3 by 2 minus 1 by 2 and it is equal to how much here? 1. And maximum value is in the same way 3 by 2 plus 1 by 2 and thereby it is 4 by 2, therefore it is 2. So in this way you can find, or else you can simply make use of minus 1 less than or equal to sin 2x less than or equal to 1. Then convert this entire inequality in terms of this one. That means multiply by minus half and after that add 3 by 2. Then also you can get this kind of answer. Got it? Now lastly students, observe problem number 6. So what is here problem number 6? Whatever the variable, let them give theta, rx, whatever it is, concept is here same. So what about here, that problem here, sin square theta plus 3 sin theta cos theta, and next the other value you are having 5 cos square theta. Understand? So again you have to observe whether we can make use of this formula. Here you observe it is 2. Again here also 2, and these are first degree sine cos. So students, whenever you come across with a concept like this, that is a into cos square theta, okay, some constant real number plus some other constant, that is b into suppose cos theta sin theta, okay, and next plus some other constant c into sin square theta. So whenever you come across with this kind of value, understand, so many times you will get this kind of value, therefore one is in second degree, other second degree, and it is cos sin. Now I want to reduce this entire value in terms of this one. Then how we can reduce? That means first degree as well as angles also must be here same. Understand? So here cos square theta, you can write how much here? It is nothing but 1 plus cos 2 theta whole divided by 2. Okay. And next here b, and this is nothing but you know the formula, it is half sine 2 theta. And next value here c sine square, and that is nothing but c into 1 minus cos 2 theta whole divided by 2. Now students, you can observe simply you got here a by 2 plus b by 2 plus c by 2, that is a plus b plus c by 2, entire thing is your constant term. Then other values cos 2 theta you can take here common, some constant value you will get, that is you got now some k plus L into cos 2 theta and plus m into how much here sin 2 theta. After you simplify the constant terms, got it? One is cos 2 theta coefficient you will get, and another one sin 2 theta coefficient you will get. Finally you got entire value into our standard form, that is angles are one and the same. After that here cos degree is 1, sin degree also here 1. Therefore simply you can make use of here the concept of this a cos x plus b sin x plus c. Now let's have a glance to this particular problem. So whenever you got now a cos square plus b sin square etc., nothing to worry, again you can reduce in our one of our standard forms. Now sin square is given there, and that sin square I am taking the last 6th problem students. Now we are solving. Sin square can be written as 1 minus cos 2 theta divided by 2, right? And next this is 3 and it is half sin 2 theta, and next value it is how much? Plus 5 times 1 plus cos 2 theta whole divided by how much here? 2, right? So in this way we reduce the entire problem. Now everywhere 1 by 2 is there, you can take common, or let us split here, it is 1 by 2, right? Minus 1 by 2 times cos 2 theta plus 3 by 2 sin 2 theta, and after that plus 5 by 2 and plus 5 by 2 times cos 2 theta. Okay, what I have done here, just multiplied, splitting the fraction, 1 by 2 minus half cos 2 theta, 3 by 2 sin 2 theta, 5 into 1 5 by 2, again 5 into 1 by 2 it is into cos 2 theta, right? And now let's have a glance on constant terms. So this is 5 plus 1, what is the value? 6. 6 by 2 means 3, and next value cos 2 theta you observe here. Understand, 5 by 2 minus 1 by 2. What is the value? 4 by 2. 4 by 2 means 2. Therefore, this is plus 2 times cos 2 theta. And next this value is plus 3 by 2 times how much it is? Sin 2 theta. Understand students? Now you got the entire problem in terms of our standard result, because angles are here one and the same, that is 2 theta 2 theta, and power is also here 1 and 1. Then what about the result? Minimum is C minus. So what is our C here? 3 minus under root of 2 square plus 9 by 4, that is here 4 plus 9 by 4, and maximum is, so this is minimum and maximum value is nothing but how much here? It is 3 plus under root of 4 plus 9 divided by 4. Now if you simplify, you can obtain here the minimum as well as maximum values. Okay, so whatever the form given, maximum to maximum we are able to reduce in our standard result. If you are unable to reduce in standard result, then also we have some other method in differential calculus, we can approach that method. Okay.